In this video, we'll be talking about slope, which is the rate of change at the same time, which is the representation of a line on the coordinate plane that has a different orientation or different steepness. So first, we had to plot a set of points on the coordinate plane to see how the points are related. So after you plot the points, our lines or the points line up in a straight line. So you would have 4 lines on each. You have a different orientation. So on each graph, after you plot the points, you should see different orientation. What that means is how the line is inclined. So on the coordinate plane, we have the right side of the graph, and after you graph the line, I'm going to put an arrow on the right side to help myself identify the orientation or inclination of the line. If we have an inclination, it is upward, will be our positive slope. Downward to the right will be our negative slope. So upward, positive slope, up to the right. Sometimes it's helpful to hide the left side and just see where the right side is pointing. Upward, that will be positive. Downward, negative. It's positive trend of points and negative. For the horizontal line, we don't have or upward or downward direction. So if I put an arrow even on the right side, we don't have up or down. It is horizontal. So the slope will be called 0, and we'll see how to use the slope formula at the same time to see why is it 0. And then for the vertical line, again, I don't have up, I don't have downward direction. The line is vertical, so I don't have the right side of the line. That will be undefined slope. Undefined slope or does not exist, or slope does not exist, unexisting. So for the slope, what we can say is that slope is the steepness of a line. And to calculate slope, we can use any 2 points. So if you know 2 points on the line, you can find the slope. So you don't need to have 5 points like I asked you to plot at first. You don't need to have too many. All you need is 2. For example, if I have 2 points on the graph anywhere, so I'm not showing the coordinate plane, and I connect those 2 points, I am going to see that steepness. If I only have 1 point, then I don't know which way is the line going from there. But 2 points gives you a good orientation, and here we have upward, so positive slope. In addition to the orientation, we need to see the rate of change, or how is the actual ratio of the vertical to horizontal distance. So by looking at my points in the first example, I have between the points a ratio that I can identify by completing my rectangles, so ratio rectangles that we talked about in previous lessons, and then calculating the vertical, or counting the vertical to horizontal distances. I have 3 to 2. If I draw a rectangle representing the ratio between the next 2 points down here, the closest 2 points, any 2 points, I still have 3 to 2, so 3 vertical, 2 horizontal. But then if I look at the next 2 points, they seem to be having a higher ratio or a lower in the next one, but it has to be exactly the same. Why? Because the ratio is a fraction, and fractions can be simplified. So these 2 are rectangles representing different size, but as ratio, they have the same steepness. So the steepness remains the same. So here we have 3 by 2, 3 by 2, and in the bigger one we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and 6 by 4 is at the same time a ratio. Ratio can be simplified, and if I simplify, divide by 2, 6 divided by 2 is 3, and 4 divided by 2 is 2. So that is the same as this 3 by 2, or this one, or this one. So the steepness is the same all the way throughout, and if it appears to be a different size rectangle, that is the same steepness because the ratio simplifies. From corner to corner, if I use the ratio 3 to 2, 3 to 2, I can place one more dot in order to complete this constant rate of change, or the same rate of change of 3 to 2 all the way throughout the line in the positive direction. So if I was to identify this slope, putting together the direction plus the ratio of vertical to horizontal change, that slope will be positive 3 by 2, or 3 to 2. In the next example, I have downward direction. Downward direction meaning to the right. The line is inclined downward, and that is negative slope. The ratio between the points is showing the vertical to horizontal change between point to point. So if I go and connect point by point to see what was my change, I have 2 to 4, and this one is 1 to 2, this one is 1 to 2, and this one is 2 to 4. Every time we read the ratio as vertical to horizontal distance, remember we need to make sure that we simplify. So if I have 2 to 4, that can be simplified to 1 to 2. So the ratio 1 to 2 is consistent or same all the way throughout, because I can complete and add more points as I move along that line. So 2 to 4 reduced to 1 to 2, which is equal to 1 to 2, 1 to 2, 1 to 2, 1 to 2. And it is downward direction. So if I was to put the inclination and the ratio together, that would be negative 1/2 for the slope. Negative because of the direction downward to the right, ratio of vertical to horizontal 1 to 2. In the previous example, we had upward, up to the right, in the ratio of 3 vertical to 2 horizontal throughout the line. In the horizontal situation, we have zero slope. Zero slope because if I move along the line, I can count distance from point to point, and let's say 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. So, but I'm not going upward, I'm not going downward. In the slope, I don't have a sign because again, it's not going up, it's not going down. The only neutral number that doesn't have a sign, positive or negative, is our 0. And that is one of the ways of thinking about slope. Then I'll show you with numbers how that works as well. So not positive, not negative, neutral line, it's a 0 slope. There is no tilt to it. An undefined slope, we have a vertical line. A vertical line, I can count these points, but I don't go up, I don't go down, I'm going straight down vertically. Vertically is undefined slope, or does not exist, or not existing slope. So undefined slope using the vocabulary. So if I say in directions, what is the slope? You say undefined. Not existent. In the slope, we again need only 2 points. We don't need too many. We can read the ratio of vertical to horizontal distance between the 2 points, and we need to make it see what kind of inclination. So pay attention to upward, downward, if it is horizontal, zero slope, or vertical. So between the 2 points, the slope will be the direction in addition to the vertical change over horizontal in the ratio that you create. In some references, you can see it as a rise over run. And eventually, we'll use the formula where vertical, we have the y difference of the coordinates. So the coordinates of y of the 2 points, y1 minus y2 minus y1. And horizontal are the x coordinates, so we're going to subtract the x2 minus y1. So you have the y difference over x difference, y2 minus y1, x2 minus x1. But we'll focus on the formula in the next video. In the first one, what we're going to do is just look at the points that we have to plot and the relationship between them. So the points that you had to plot are represented by the line that is going upward to the right. Again, on the right side of the coordinate plane, we have upward and downward. If the line is stretching upward, that is a positive slope. So upward is a positive slope. So the sign is positive. Then we need to see the ratio of the vertical change to the horizontal change. So from point to point, I am using my ratio rectangle and see vertical change 2, and then horizontal change 1, 2, 3, 4, 5. So 2 to 5. The ratio cannot be simplified. That becomes your final answer for the slope. What kind of slope, meaning what kind of tilt does this line have? The tilt is upward 2 by 5. To check that, we can go from this point and see if that works one more time throughout the line. So go on 2, 1, 2, 3, 4, 5. In order to double check, we can see the relationship. Next 2 points, 0, 2. Remember, in order to plot them correctly, if we are mixing up where 0, 2 versus 2, 0, x, y. So x is 0, y is 2, 0, 2, ordered pair, and then 3, 0. By connecting the 2 points, we see a downward tilt, downward to the right. So we always look at the right side of the graph. Right side of the graph, sometimes it's helpful to hide the left side so you see the downward direction. So that is the sign of the slope. The sign of the slope is represented by the direction of the line. Then we need the ratio of vertical to horizontal change. So vertical to horizontal change from point to point by drawing the ratio rectangle. 2 down, 3 across, 2 vertical, 3 horizontal. So 2 by 3. So the slope is the steepness going downward 2 by 3. Going downward 2 by 3, that ratio can be repeated. In the next 2 examples, after we plot the points, how points are on the line. On the line that is represented by a negative orientation or direction, because our line is pointing down to the right. So down to the right is negative slope, negative direction. Direction is one of the components of reading the slope. Then we need to read the ratio of vertical to horizontal change, or rise over run. So I have 2, and then 1, 2, 3, 4, 5, 6, 7, 8, which is the bigger rectangle, but it's the same steepness. So we need to see if here we have vertical 1 by 4 is the same steepness after it is being reduced. So I have 2 8s But if I simplify 2/8, I have my negative, which is the negative orientation, 1/4, which is the smaller rectangle. The two rectangles represent the same steepness of negative 1/4. So if I go from this point 1 across 4, I can put a point, and then if I go from there 1 across 4, I am ending in this corner. And if I go again 1 across 4, that same rate of change works throughout the line. Connecting the points, positive orientation, reading the rate of change from point to point. All we need is 2 points, but I'm using here 3 just so we can prove that if two rectangles have the same ratio, that is the same steepness. So we have 1/3, 1 vertical, 3 horizontal. And then this one I have 2, 1, 2, 3, 4, 5, 6, 2/6. 2/6 is reduced to 1 to 3 by division by 2. So if I have the ratio of 2/6, I can simplify the fraction and have the ratio of 1/3, positive, because it's positive orientation of the line. In the next example, line up to the right. Up to the right means positive slope. Ratio from point to point, we need vertical over horizontal. Completing the ratio rectangle from vertical to horizontal, 1, 2, 3, 4, 5, 6 by 3, 6/3. Vertical to horizontal change can be reduced because 6 and 3 can be divided by 3. 6 divided by 3 is 2, 3 divided by 3 is 1, so I have the slope of positive because upward to the right, 2/1. Let's check that ratio. So from the point, if I go 2/1, I'm on the line. If I go again 2/1, I'm on the line. If I go again 2/1, I'm on the line, and I can extend that ratio all the way throughout the line, and the points have to be evenly spread within the rectangle. I have this 3 times. In other words, my bigger rectangle was reduced by 3 to get 2/1. So these are the 3 sections right here. 2/1, 2/1, 2/1, 3 times. In the vertical situation, we have undefined slope, or the slope of the line does not exist. That is undefined. Line going downward to the right, that is negative slope. So first, when we read the slope, we need to see the inclination. That is downward direction. Then the rate of change from point to point is represented by the vertical over the horizontal distance of our ratio rectangles. And then we can simplify ratios, so make sure that we always check if the ratio can be simplified. We have to. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So the ratio is 6/4 going downward to the right. But we can reduce by dividing by 2. The 3/2 will be my final answer, and I check it by making sure that that ratio works throughout the line. So downward we go 3/2, 3/2, 3/2, fill in another number, point, 3/2, and we can keep going all the way throughout the line, and it will work consistently. And for the horizontal line, we have 0 slope. 0 is a number, so you have a direction to the right, but it's not positive, it's not negative, it's neutral on 0, 0 slope. We can say 0, or actually spell it as upward. So the 4 situations that you can have for the orientation of the line are upward to the right positive, vertical undefined, downward to the right negative, and horizontal slope is 0.